Welcome to the empirical formula of copper chloride. Today's lab, we're going to be using gravimetric elemental analysis to determine the empirical formula of copper chloride. Gravimetric elemental analysis is used for the quantitative determination of an analyte, in this case copper chloride, based on its mass. We will be reacting copper chloride with zinc metal to produce copper metal, where we can weigh the pure copper metal and work backwards to determine the moles of copper and of chloride in the initial copper chloride molecule, thus the empirical formula. This analysis doesn't tell us how much of each atom exists in one molecule of the compound, just the ratio of elements that occur. The simplest whole number ratio will be the empirical formula. So in our experiment today, solid zinc metal will be reacted with an aqueous solution of copper chloride. So we have Zn0. Well, it's not Zn oxide. It should be a little zero. There you go. Because it's neutral. And then CuClX. So we don't know what the oxidation state of the copper is, right? Because our chloride is always going to be Cl minus. So we can have Cu 2 plus, which is very common, Cu 1 plus, which is also common. I have some in my lab right now. Cu3 plus, which is less common, but can be stabilized in some circumstances. So we just don't know. And we're going to figure this out because this is a redox reaction where the copper is going to be reduced from this unknown positive oxidation state to 0. So I don't want to write it so it looks like an equation. So I'm just going to put it below, I guess. Cu0. So it's going to become copper metal. Right? And the zinc is going to be oxidized from zinc metal, which is a 0 oxidation state, to 2 plus. Zinc is almost always 2 plus on oxidation, especially in the conditions that we can simulate in our laboratory. So this goes to Zn2 plus electrons. There's that part of the reaction. I feel comfortable writing this one other than my handwriting because I know what the oxidation state is, so I know how many electrons to put there. So we're going to determine the mass of copper chloride from the volume we will be using. We are going to be using 25 milliliters of CuClX. This is in water. Originally, this was 80.7 grams of this copper chloride was placed into a liter of water. We are also going to weigh our zinc piece. This zinc piece contains zinc in extreme excess. It's a big piece of zinc compared to the amount of copper chloride that we're putting in there. So this is going to make our copper chloride our limiting reagent. When the zinc metal is no longer reacting, it means we've consumed all the copper chloride and produced the maximum amount of copper metal possible. From the mass of our copper, we're going to assume the remaining mass is from the chloride in the copper chloride. Converting the mass of copper and chloride to moles and dividing each by the smallest value is going to give us our empirical formula. We can also use our gravimetric factor, which is the ratio between the mass of the elements in the compound. For example, we know from the reaction above that each mole of zinc requires 2 moles of the chloride, right? It's always 1 minus, and this is always going to be 2 plus. It's always going to be a 2-to-1 ratio. Or 1 to 2, because zinc comes first, because it's positive. So the ratio is 2 times the molecular weight of copper, which is 35.45 grams per mole, divided by 1 times the molecular weight of zinc, which is 65.38 grams per mole. And when you're doing these equations, I'm sure you already have great habits from Chem 1 and maybe Chem 2, but just make sure you're always including your units, especially as you get into things like exams or into further lab classes like analytical. Making sure you're in the right units at the end is really important, and noticing which units cancel out is super important. So just get in the habit of including your units and not multiplying bare numbers together. The ratio of these is 1.09. So we're going to use this factor to multiply the mass of the zinc reacted to equal the mass of the chlorine reacted. So I need to put a point there. So that's the mass of the zinc times 1.09 equals the mass of the chloride reacted. From the empirical formula of copper chloride, you will also be able to write the full equation for the reaction of copper chloride with zinc. Based upon the stoichiometry of this equation and the amount of zinc used in the reaction, you'll be able to calculate the theoretical yield of copper for the reaction. By comparing the theoretical yield and the actual yield of copper you determined, you can determine the percent yield for your reaction. And there's nothing left to do but the experiment right now. We're going to show you how we set this up. There are a couple of notes that I want to do for when you do this yourself. So right here we have our ring stand. There's no ring on it, but it is the stand. And then you're given this filter funnel. And this is a clamp here. And we want to make sure of two things when we set something like this up. The first thing you're going to make sure of is that you always have the funnel sitting on the base of the stand. Some students will like to set it up so that the base is, on the other side and this is on the bench top. And that is a great way to spill your experiment everywhere. So we want to make sure that this is on the base because this will keep the entire setup from tipping over. Even if it gets a little annoying to move your clamp up and down, if it's a little hard to move, there's like a little screw, like twist screw that you got to do. It's worth it. So you don't use your copper. And then, so you clamp this. There's a little like arm on this guy. This is so easy to see. I'm doing great at art. And we're gonna attach that to a hose. And we're gonna attach that hose over here. This is the hose. To the sink. Here, I'm gonna make the sink a different color. Our sink has a special attachment for this aspirator. So that's the sink. There's some water. Here's some water in here too. Then on top of that, when we turn the water on, then what's going to happen is that this is going to form a slight vacuum because what we've put up here is first a rubber like gasket that should fit in here. It's a rubber stopper with a hole in it, and in that hole we place this. Oh, we picked the wrong color and we erased things. There we go. This filter funnel with filter paper in it. We're going to put that through the hole in our rubber stopper. And that's going to form a seal, and that's going to make a slight vacuum. It should make a strong vacuum, but it's going to make a slight vacuum. One of the things you can do if you're not making a good vacuum when you have this, make sure you have the water turned like all the way on. And definitely talk to your TA before you pick your sink, unless you've been assigned a sink already if you're in a new place, because there are a couple of sinks that leak pretty bad when we do this. It's good to be aware. If you're at one of them, we can put you at a different one, hopefully. But anyway, if you have problems making a seal over here between the top of the flask and your filter funnel, you can put a gentle, even pressure on the top. I'm trying to draw a hand. That's a beautiful hand. It's the best hand I've ever drawn, honestly. You can put a gentle, even pressure on top, but you want to do that without making a seal because it'll suck your gloves down and then you'll lose some of your copper. So instead of using your whole palm, if you use like 2 fingers on each side, here's your 2 fingers because you're a lobster, and push down gently and evenly, then that's a great way to help make sure you get that seal. And just make sure that it is even pressure so you're not, pushing it further to one side. And then it is also firm but gentle. You don't want to push too hard and end up getting hurt or slipping or breaking something. So just be mindful of your technique, and especially if this is the first time you're doing something like this, make sure to come forward and ask your TA or the lab personnel if you need any help or any guidance, or if you're unsure of anything. We're here to help you. Even during these virtual labs, we're here to help you. Please reach out at any point if you have any questions. We're all one big team, and our whole goal is to make sure you understand what you're doing and you do it well and safely and can take these skills forward. So with that, we're going to start the actual experiment.
So right now we're doing the empirical formula of copper chloride lab, where we have our pre-weighed zinc piece. I've measured out 25 milliliters of an 80.7 gram per liter solution of copper chloride. And our first step is going to be, we're going to add the 25 milliliters of the copper chloride carefully to a 250 milliliter beaker. And then what we're going to do is add the zinc piece carefully. We're going to tilt it at an angle and let it slowly drop down. And notice now the zinc piece has gone from, a silvery metal to now it's very dark. It's a very dark color. And you can see some chunks are coming off. What we're going to have to do is we're going to have to scrape the surface of the zinc, because it's currently reacting with the copper chloride to form zinc chloride and copper metal. And these chunks are what we see of the copper metal. So one thing that you can do is place one of these, these glass stirring rods, thank you. Hold down the zinc piece with one and just scrape with the other, obviously being careful that you don't shatter these glasses, but the faster and harder that you scrape, the faster that this whole process works. This will take a while. And Corey, you want to have a top view?
Yeah, let's do a top view.
Yeah. So if you notice, you see like scratches are appearing and they're quickly going away. That is the copper chloride quickly reacting with the zinc surface. So we're just going to keep on scratching until once we see scratches, and then if the scratches stay on the surface, we know that all of the copper chloride has reacted with the zinc metal. So right now we're going to see how to check if the solution has gone to completion. So what we're going to do is on this zinc piece, very black, we're going to scrape and see that there are scratches showing the clean zinc surface. Do you see that?
Yeah.
So you see the scratches. So now we're going to carefully let the copper chloride solution wash over it, and we're going to tilt it back, and you see that the scratches are gone. That means that the copper chloride is still reacting with the zinc surface, forming this dark copper surface on top of the zinc. So we're going to, I'm going to keep scratching, and
Check back in a minute.
Yep. You can see that when we scratch the zinc piece and we put it underneath the liquid and let it sit for a little bit and we bring it back up, we still see some scratches. So that means that the zinc surface is no longer reacting with the copper chloride solution and the reaction has gone to completion. So right now we're going to add about 10 drops of hydrochloric acid to our beaker. And we're going to stir that pretty good. Notice that it looks like a lot of the chunks are sticking together. Make sure that these are pretty clean. so that nothing comes out. And then we're going to grab this zinc piece with our tongs. And, oh, actually, let me get a piece of paper towel first. So what we're going to do is you're going to remove the zinc. And actually, we're going to put the zinc in this beaker of just distilled water to wash off any excess copper pieces. So notice that there's maybe like, some small chunks there at the bottom. I'm then going to remove this zinc piece. And we're going to dry it and then subsequently weigh it. Now with this excess copper that's in here, we're going to rinse it, or we're going to swirl it, dump it right back in there. And yeah, it looks like no copper's in here.
Can you get that stuff off the edges of the beaker, maybe with your stir rod?
Huh?
You got that residue on the sides.
Oh, like all this stuff?
Yeah.
This is just dried copper chloride. There's like a little bit left, but it's like an insignificant amount.
Okay.
Yeah. So as you can see, we have a lot of distinct chunks of our copper.
Oh.
Okay. So now that we have all of the copper chunks back into this flask, we're going to decant off the supernatant liquid, which would be our zinc chloride. And we're just going to carefully decant all the liquid while keeping the copper chunks, the copper solid, in this beaker. That's pretty easy. So what we're going to do now is we're going to wash these copper pieces with, maybe approximately 10 milliliters of water. So we're just going to rinse them like so. With our distilled water, we're going to swirl it around, let it settle a bit. And we're going to decant. One more time. So we're going to want distilled water in here. Maybe about 10 milliliters. Or more, but not too much. And this is what we're going to be pouring into our Buchner funnel. So here's how you set up the Buchner funnel. So we need a ring stand. What we've done is we've clamped our sidearm flask on here first, and then we have this hose that's attached to the sink. What'll happen is water, we open it up, water will come through and it'll form a vacuum, and it'll suck air, in here, down in through the hose. So right now what we'll need is first we're going to have this rubber ring, and you want this edge up for when you add this funnel, the ceramic funnel, it'll sit nicely on this rubber ring. And finally, we want our filter paper. We're just going to place that right here. So right now, we are ready to turn on the sink. And I'm not sure if you can hear it, but you can hear sort of like a vacuum noise. Yeah. Make sure there are things that you don't want to do. One is you don't want to put your glove on here. It'll suck the glove into the vacuum. When you try to pull it off, if you have any sample, it might just pop and go everywhere. So right now we have our copper solid, and we want to carefully but quickly dump it in here. And it's okay if you don't get everything. see we still have a lot left, but what we're going to do is we're going to wash this out. So now it looks like the water is slowly dripping, but we can carefully squeeze down and allow the water to drip down into the flask itself. So you can see that it looks like a lot of the water has disappeared from the top. It is filtered on through into the bottom. So what we're going to keep doing is we're going to add a little bit of water to here. And just continuously dump it. One thing we could do is we can squirt this and allow it to fall. The one thing is you don't want to add too much liquid that you'll have the level of liquid in this beaker, this waste beaker, all the way up so that it'll get sucked up into the hose. You don't want that.
Also, the more water you use, the longer it'll take to get dry.
Yes, that is true too. Okay.
All right, we're gonna let this filter.
So now that we've allowed all the water to filter into the bottom, we're going to be washing this 3 times with 10 milliliters, about approximately 10 milliliters of acetone. Just to wash, you know, you want to get it all around the sides. You see it's getting dry. So just a little bit more acetone just so we can serve our acetone, even though it is sometimes it squirts out of the bottle. And one more time. Notice how I'm doing it around the edges so that some of the copper doesn't go underneath the filter paper. All right, so now we're gonna, we've let this dry onto the aspirator for about 5 minutes. So now we took it off and we're going to try to carefully put this on the weighing paper.
So I folded the weighing paper slightly so that we have some edges in case the copper starts to go everywhere.
Yeah.
I don't know, that's not a required part of your lab, but I think it's a good way to do it.
Yeah.
It's important when you make this little package that you keep the bottom of it flat. This way your copper all kind of pours evenly on the center and it's not flopping around or blowing across.
We're going to also be weighing the weigh paper too, because there's a lot of copper that's actually in the weighing paper itself. So just dumping everything. That's okay. Everything's pretty much on there. So we're going to carefully bring this over.
So we've waited our extra 5 minutes, and we are within an acceptable difference. It was like 0.002.
0.05 or something
Okay.
like that.
Well, we are at 0.002, so very happy with that result. We're going to dispose of our copper and our zinc in our solid waste, and then leave you guys to do the calculations. Have a great rest of your day.